Well, hello guys, here Mr. G with another video. This is for the grade 12 and it's also related to the organic chemistry. This time we're going to be talking about the properties, which is quite important, and it would be question 3. This question was question 3 from September 2023 done in the Eastern Cape province. Now, I'm going to leave the question in the description below so you can answer the question before watching the video. But before we carry on, don't forget to subscribe for the channel so you can get all the notifications and videos I post on regular basis. This question says compound A to C are used to investigate factors that influence boiling point of organic compound. The table below shows the results obtained. You have 3 compounds and you have the boiling point for each of those compounds. Important. Each of these compounds, all of them are alcohols. All these compounds here are alcohols. All of them are alcohols. Now, alcohols will have 2 intermolecular forces. The most important one is hydrogen bond. And the second one is London forces. The main one is hydrogen bond, as I said, which is the stronger intermolecular force, but it also have London forces, okay? So that is an important thing. Second important thing is all these compounds are in straight line and all of them are increasing by 1 carbon. And the numbers I'm going to write here is the number of carbon. This is propan 1 ol, so is 3 carbon. This one have butane 1 ol is 4 carbons, and the last one C have 5 carbons. So the only thing that changed was the number of carbons. The chain became longer. Okay, so the first question here, 3.1, is define boiling point. And here we are. What is boiling point? It's the temperature at which the vapor pressure equals the atmospheric pressure. Those are the most important part, and if you say that, guys, you will get 2 marks. It's a definition which a high probability of being asked in the exam. Please don't make a mistake with that one. For this investigation, write down the independent variable. Now remember, the independent variable is the variable you changing. What did you change in this investigation? We already see the number of carbon, so we are going to write here, instead of number of carbon, we are going to write the chain length, for instance. You can also write here for example, surface area, or even a molecular size. I'm going to keep it like this: chain length, surface area. Note that is what we actually change. I think if you write number of carbon in the main chain, it will also be accepted. I think it will be the correct thing. Now there's 1 mark for that one, guys. It's quite simple. Control variable. What we kept constant here, and be careful, we kept constant, all of them are alcohols. So we kept constant the functional group. The functional group was kept constant. That one is the control variable. Which one will be the dependent variable? Boiling point. It's not part of the question, but if they ask you to identify the dependent variable, is the boiling point. The boiling point depends on the number of carbon you add in, which is each of those alcohol there. If you do that, you will get another mark. Guys, so far we have 2, 3, and 4 marks. We have 4 marks out of 17, which is not bad. 4 easy mark. Now name the intermolecular force that is responsible for the observation turn in the boiling point. Now note, all of them will have a hydrogen bond which does not change because you have only 1 functional group. So this one do not change. The one that is going to change is the London forces, because it will make as you make the chain longer, there will be more side for London forces. So it is no hydrogen bond, but instead London force. So be careful with that one. So the answer here is London forces. London forces can also be called induced dipole forces or dispersion forces. I'm not going to write all of them, but London forces, either one. Note, hydrogen bond is not the ones responsible for the change in boiling point. Why? Because all of them will have the same hydrogen bond. The only difference is as they come longer, as you move down from A to C, there is more site for London forces, more surface area, but not the hydrogen bond. Hydrogen bond stays constant. That one could be tricky if you don't read. Please read the whole question. The boiling point of 3 branches alcohol are given below. Now they give 3 different boiling points from a compound that is not in there. It's a new compound, which in this case is going to be 2-methyl-butan 1-ol. Now, let's see, because this question I think is a little bit more tricky than the other ones. We are working with this compound and they give us 3 boiling points to identify which one could be the boiling point for this compound, which is not in the table that we have there. So it could be tricky. Now, how are we going to approach this one? First of all, we are going to find out where can we allocate that compound in this table. All right, so we're working with but. So because we're working with but, this compound will be better allocated in between B and C, somewhere there between B and C. So we are going to see the following. We have butan 1-ol, but we have here butan 2-methyl-butan 1-ol. So apart from the butan, you also have a methyl, which is making this compound bigger than butan 1-ol. So 2-methyl-butan 1-ol is bigger in mass than butan 1-ol. However, it will have less surface area than pentan 1-ol. Pentan 1-ol is longer, so it will have more surface area. So that is what we have to do. We have to compare both of them. The correct answer will be a temperature that is in between the two of them. So it will be 129, and if you do that, this one is the correct answer. If you do that, you will get 1 mark. Why 128? Because it's greater than butan 1-ol, but is smaller than penta 1-ol. So let's explain fully here for the question 3.5 what we're supposed to say there. So the first thing you have to say is that 2-methyl 1-ol has larger mass than butan 1-ol, and you will get 1 mark. That is the first comparison. Because it has a larger mass, it will therefore have stronger London forces. No hydrogen bond stays the same because we're still working with 1-ol. Then you'll have to say that the stronger London forces than in butan 1-ol, and so it will have higher boiling point. For saying that, guys, you will get another mark. So we now compare 2-methyl 1-ol with butan 1-ol. That is the first comparison. Now we have to compare with the pentanol. So now you start comparing with pentanol, and you'll say that 2-methyl-butan 1-ol has shorter chain than pentan 1-ol. If you say that, shorter chain than pentan 1-ol, you will get another mark. As a result of the shortened chain, we'll have a weaker intermolecular force, in this case is London forces, than pentan 1-ol, and therefore lower boiling point. And to finalize here, you have to say that have a weaker London forces than in pentan 1-ol, and so will have lower boiling point. And if you say that, you get another mark. This is a total of 4 marks for that explanation, and it's not that bad, guys. It's not that bad, but it could be a little bit more tricky. So let's go to question 3.6, and we're almost done with this question. They say temperature, the graph below represents the relationship between vapor pressure and temperature for propan 1-ol and propanol. So we have a propan 1-ol and propanol. Real fast. Propanol, we already spoke, it have hydrogen bond apart from the London forces, right? And the aldehyde, propanol is an aldehyde, will have dipole. Okay? That is important. And just for control, hydrogen bond is stronger. We are writing important information here. Now the question says define vapor pressure. And the definition for vapor pressure is the pressure by a vapor at equilibrium with its liquid in a closed system. If you say that, guys, it's 2 marks. And this definition is another one that is a high probability of being asked. Which curve P or Q represents the graph for propan 1 all. Now, note the following, and this is just a recall. The stronger the intermolecular forces, the lower the vapor pressure. Okay, let's fix this one. There we go. The stronger the intermolecular forces, the lower the vapor pressure. In other words, whoever have a higher vapor pressure will have a weaker intermolecular force. If we go here, P will be for propanol. This one will be propanol here. This one will be propanol, and Q will be propan-1-ol. Nothing to say about that. So which curve P or Q represent the graph of propan-1-ol, and that one will be graph Q. Q will be the correct answer here. If you say that, you will get 1 mark. Very easy, guys. And at the end is explain your answer by referring to the type of intermolecular force. We already explained here. We already explained there everything, but let's write it down. Let's write it down how you're supposed to write it in the exam. So here, the first thing you have to do is to identify the type of intermolecular forces. This one for saying the propan-1-ol have hydrogen bond, and this one mark for saying the propanol has dipole-dipole forces. Both of them, guys, we identify at the beginning of this part of the question. Now we have to compare. And there is one mark for comparing. Hydrogen bond is stronger than dipole-dipole. And the final mark is for the conclusion here. Now in this case I'm going to add something about energy because it's not part of the question, but it's always there. So the stronger intermolecular force, more energy need to break them, lower vapor pressure. Guys, this is the end of this question. There are 4 marks for that one. I hope it helped. It's a very good question. It's 17 marks in total. I'm sure you can get all those marks 100%. It's quite simple and it was a good question. Thank you for watching, and I really hope it helped. Next time we're going to be making a video on organic reaction. This one could be a little bit more difficult. Don't miss that video. But thank you for watching. Thumb up, subscribe for the channel. I'll see you next time. Mr. G here.